video, we'll be looking at the sine rule. We've already worked out when to use it, so this shouldn't be a hard lecture at all. It should be short and easy. But for starters, I would ask my questions to solve this problem here, where you've got two circles tangent to each other, and you've been given the radiuses of each circle, and you have to figure out what's that distance x there. So pause the video, have a go ahead, and then play the video and watch the rest. So to figure out the length x here, one way to think about it is that you've got what? It's all about uh, thinking outside the box. This length here is 4 plus 6, right? Which is a 10, right? So that radius of two circles is telling you that's a 10 here. All right. And the fact that you've been told that they've kind of drawn you a right angle triangle in the shape as well. They didn't have to do that. But they've just told you that this line is extension of this tangent over here. So you see, if I label this angle theta, all right, the ratio of this side opposite to hypotenuse, so 4 over x must equals to, because this is really sine, this ratio is called sine theta anyway, is the same as the sine of the theta in the larger triangle. The larger triangle has side 6 divided by x plus 10, right? Because the hypotenuse of the larger triangle, the red line, if I extend that, yeah, it's x plus 10. So solving this equation will tell you what x is. You just simply cross multiply. You get 4x plus 40 equals to 6x. Take away 4x from both sides, so x is 20. Easy peasy, right? Now, if you have to look at the part B, calculate the gradient of the line labeled x as a percentage. Alright, so what they're saying is that use this ratio that you just found. Now we know x is 20 and 4 is the opposite side. You know this theta here, alright? What's this? Well, gradient as a percentage is just rise divided by run. So we just need to figure out the bottom side or adjacent side of this triangle here, and to do that, you actually don't have to use trigonometry. You can just use Pythagoras. So you can say 20 square minus 4 square square rooted will give me the adjacent side of the triangle. And why am I looking for adjacent side? Because gradient, if you remember from earlier chapters, is rise over run, which is the adjacent side. So 4 divided by the adjacent would be the gradient. So I may quickly put that on my calculator. So 20 squared is 400 minus 16, and the square root of that is 19.5959. So we are dividing 4 by 19.59. Alright, so as a percentage, it's 20%. Alright, so the answer here is 0.2, and I'll round it down to 20%. Alright, so that answers part B as well. Alright, part adjacent was part B, and gradient is part. Alright, so very quickly, there are just two questions here about sine rule. We know whether we need the sine rule or cosine rule when you ask yourself, do I know an angle and the opposite side to that angle? Yes, the answer is yes. So sine rule is applied. We're going to write it because in this case we do have the angle and the side is missing. We're going to go for one of these rules here. It's easier to use that rather than rearranging the other one when this angle is on top of the fraction. So that's why We're just going to substitute those values into it. So we can label what? We're going to label 8 to be little v and 34 to be capital V. Alright, and substitute and rearrange, multiply both sides by sine 82 and put it on your calculator. You should get 14.70. Alright, easy peasy. Once again, you've been asked to calculate this angle here, and you know the opposite side and the opposite angle to it. Okay, 15 is opposite 32, so sine rule applies. We're looking for an angle, so we're gonna take the sine rule where the signs are on top of the fraction rather than like denominator. So you're going to just simply substitute into the formula the the last step. This question has one extra step in the end because you have to take the sine inverse of both sides. So sine inverse, I wouldn't I wouldn't write decimal numbers right so because they're dangerous. Some people rounding these decimal numbers is gonna be a bad idea because zero point 0.4 here, that the degree of accuracy, yes, you do need up to 4 decimal places if you. So I would simply type in my calculator sine inverse of the 12 times sine 32. Just write, you don't have to evaluate it and show the examiner decimal numbers. If you write this in the exam and say theta is so, they will give you the same amount of mark as they would have here. Because some people run decimal numbers, like if I type in my calculator sine of zero point 0.4 or just even 0.42 is not as accurate as having 0.4239. All right, you're rounding up uh, these because sine has all its digits go from 0 to 1 and 0 to -1. But later when we check out the graphs for sine, so those degrees of decimal places tell you a lot how far up this uh, function you are. The sine curve looks something like so, and like if you're here and if you give your calculator value slightly less or slightly more, you're gonna end up actually a long way out. You're gonna have a big difference in your answers. Okay, so the final answer is going to be 28.08, which we round up to 28.1 degrees. All right, so that's its lecture over, and I'll see you in the next video.